Okay, I think we're live. Share my screen. Okay, before we get an update from individual person, let's first take a look at where we stand as to our OKRs. I think we've actually made quite some progress for the two, both in terms of single sharded mainnet and also sharded MVP. So on the single sharded mainnet side, I think the memory leak investigation is going very well. I think we kind of fixed two of the three major source of leaks, and now we're just heading to the investigating of the memory leak inside our Rust code, which is supposed to be easier than investigating dependencies. So well, I'm pretty confident that we can get this done by the end of the year. And also the nightly feature flag things going also relatively smoothly. We're just we now will have BigNet deployed on every 24 hours with the nightly feature flags. So that's also going fine. So for syncing, I'm not sure. We'll get an update from Alex later. But I think we're also on track there. So on the sharding side, I think Michael is still investigating. There's some unknowns, but hopefully we can figure out relatively soon. I think there are some stuff here that we might not be able to finish before the end of the year, but I think that's somewhat expected. So we'll see how far we can get. Okay, let's get an update from. Let's start with Michael. Michael, are you here?
Yep. Yeah, so like you said, we're still investigating the 8-shard network. So far, we've got data indicating that something is not working as intended, though it's not totally clear what that is. I talked with Alex today about it, and he had some ideas about what or where to look more closely to see if there are issues, and I'll do that today and tomorrow, and hopefully by next week I'll have some more concrete issues to report, or even better, fixes for those issues.
So to be more specific, the issue that you're observing is that sometimes it takes a long time to apply the block, right?
Probably. It's specifically the data that we have shows that sometimes it takes a long time after receiving a block and before making a chunk. And Alex pointed out that this actually could be because we are waiting to receive the chunks for that past block. And so it's actually a network bound thing, not necessarily a CPU bound thing. Although that itself is weird because we do have this chunk forwarding feature enabled where chunks are supposed to be, or like parts of the chunks are supposed to be forwarded automatically to the owners. And so there shouldn't be this back and forth of having to request chunks, but it seems like that is still happening. So. So maybe the chunk forwarding feature is not working as well as it should be.
Yep. Yeah, I mean, we can definitely look to see whether the nodes, for example, are still requesting chunks, and also how long does it take from
Yeah.
when you receive the block and when it has the chunk ready to be applied.
Yep. Yeah. I could add logging for that. The delay detector that you wrote, Bowen, was also enabled in that run, and the most frequent delay detector trigger was from partial encoded chunk response, which would only come, of course, if there was a corresponding request. So definitely nodes are still requesting chunks, even though that it should have to happen relatively infrequently. I would expect, but
yeah, we'll need more data to see what's happening there, and I think that delay, that's simply because it's kind of unblocks some blocks, so it takes some time to apply the block. I think that's why.
Yeah, that's most likely the case.
Yeah,
but it still means that there was a time where the node didn't have the chunk and so had to go ask for it.
Right.
Should happen very infrequently if forwarding is working as well as we would hope it would work.
Yeah. Okay. Well, I mean, maybe the first step is to check whether it's properly enabled, right? I mean, we can.
It's definitely enabled, yeah. So there are some delay detector entries for partial encoded chunk forward.
I
which
see.
Of course,
okay.
Yeah.
Okay.
It only exists with the feature, so.
Okay. Oh, yeah, sounds good. At least we know it's enabled. Yeah. Okay. We'll wait and see what. Hopefully, we can get more information this week. Let's see. Piotr, how's everything going with the rest of the investigation for memory leaks?
Yeah, so it looks like for Wasmer we don't see any memory leak. For LXDB, I figured it out. Right now I'm running a node and I see that the memory has not increased since yesterday, and I've been running it for 2 days. So I think it's probably the issue with the RocksDB is solved, but just to be sure, I should just run a node probably for a week and make sure nothing else happens. And in the rest code, I also need to just run it for more time and just make sure there are no more leaks. I mean, even if there are leaks, they should not be big. And I need to make some improvements because I see that for some reason I was not getting stack traces for some of the memory allocations, but I should be able to figure it out.
So currently we set the RocksDB overall cache size to be around 2 gigabytes, right?
Yes. But we could also reduce it to maybe like a quarter.
I mean, sure, yeah, but we don't have to be that aggressive. I think 2 gigabytes there, it's fine.
Yes, but
yeah, I mean, we can maybe do this in the future if we want to like have lower spec machines and people can, and then we can do more optimization.
That's one thing, but I also still want to know if the reduction of cache size that I made, did it actually make any difference or not? And it would be good to have at least some kind of benchmark to see if that actually made a difference. And then we could choose just the proper value that makes sense.
By making a difference, you're talking about performance. You're not talking about memory, right?
I'm talking about the performance. Whenever there was like a performance issue with the change that I make, since I don't have any numbers to say that whenever.
Yeah, I think we can do that in the future. Right now, I think the focus is more on just getting the memory usage to be stable, not to have it growing every day. And after that, maybe if we need it, we can try to understand better where what's the lowest number we can push there.
I mean, it's not only about trying to figure out what's the lowest number you can push. It's also about just making sure that the changes that we made didn't break something, didn't decrease the performance.
Sure, yeah, but I think, I agree. But performance, I think measuring and benchmarking that is part of this process, right? To understand where what is the kind of minimum requirement, or
I mean, it's let's say I go next day, make some change, and who knows? Maybe I made the node 50% slower, and we don't know.
Yeah.
Right? So I made some change that reduced the memory size, but I see that the node is still working. But then if there was some performance degradation, I wouldn't know.
Sure. Yeah.
But they can happen also for any other reason, not necessarily because of my change, but because someone else make a change. And then you might spend a lot of time investigating why the node is not working later if we don't have any kind of tests that can show that we keep some level of performance.
Yeah, that's a good point. We definitely can work on this later. So what about investigation inside the our Rust code? Is it so how many memory leaking there?
I mean, for sure, I don't have any. For sure, if there is a memory leak, it will be like some small memory leak. I just I don't have enough data to confirm if there is any.
Oh, I see. So you're saying there may not be any, but that's
there might be not many, or there could be like some that's small, like less than 1 megabyte an hour.
I see.
Because it's for some data structure, it's hard to tell. For example, if you have some data structure that gets allocated from time to time, that gets freed, that gets allocated, gets freed, and depending on when you actually measure the number of allocations, you might see that I might see that there was some kind of growth, but it's not. It's certain because it could go down and then up again. So I should set up an instance and then try to do memory dumps every hour and just make sure, just look at for each of the locations how many we have.
So can we get like just overall sense, like you know, how much it is, how much memory is growing every day, for example, and I think what did we put in the OKR? 5 megabytes per day, right? If we observe less than that, I think we don't. There's probably not a need to investigate that at the moment. But yeah, I think it'd be good to understand on the kind of higher level, right? How much growth we're seeing every day. Maybe that requires you to run the node for a longer period of time.
Let's see. I should have some data. So let's see, like period of 18 hours. If I can compare like two nodes.
I shared a dashboard in Grafana where you can see both CPU usage and memory usage across the networks.
I mean, I have the more detailed, more sophisticated stats which tell me exactly for each allocation how much memory we use. But anyway, I can also take a look at it later. I mean, in the instance that I was running in like past 24 hours, the memory increased by 5 megabytes.
I see.
This is when running with my configuration. But this was when I was running with a configuration that actually uses slightly less memory. It sets limits that are slightly lower than what I set. I think I said like 500 megabytes limit.
I see.
This was just easier for me to test because then I assumed it would take less time to reach the maximum amount of memory. So I saw like 5 megabytes growth in a day. But then there could be like some variance. Like it's possible that
sure. Well, yeah, maybe we should run it to measure it over a period of a week or something like that.
Yes, I want to start a new instance and then just keep it running for a week, and also write a small script that just runs my tool, let's say every hour, and then we'll see how the growth is.
Sure.
Just to make that should. Anyway, I don't have any reasons to believe that there are still any memory leaks left, but I should just check and make sure.
Okay, that sounds great. Yeah, if it's less than like let's say like 5 megabytes per day, then yeah, let's not worry too much about for now.
I mean, even if it's like 50 megabytes a day, then in let's say a month, you'll grow by 1.3 gigabytes. So if right now my code is, if right now I see memory usage of, let's say 1.6 gigabytes, then it should still, even assuming we grow 50 megabytes per day, it should still work for at least let's say 2 months before it reaches 4 gigabytes.
Right, but was there? Yeah, I think there's a difference between like you have to reset it every like couple of months and having to reset it every year, and like if on the like if it requires a year for it to grow to some significant level, I mean, we would definitely have more upgrades in the year, so you would definitely have to restart your node more frequently than once a year. So
if we are in the situation that the memory was growing really high, you would have to probably reset it every day. And right now I need to do just the longer term investigation. I also need to fix small things, and then we can make sure. It would be probably good to, I mean, later on, we can also look at the Grafana stats later on and see what's the behavior.
Well, but those are not running with I think the latest config, so we'll have to change something there. But yeah. Okay. Let's see. Misha, are you here?
And later on, you also mentioned that we should prioritize trying to add like some performance statistics.
Yeah.
And I will also have some questions about that, because there are a few ways to do it.
Sure. Yeah, but we can discuss offline. Yeah.
Yes, I'm here.
Okay. What have you been working on?
I pushed a partial fix to the orphan attack. And I sent a pull request for chunk mask fix.
Oh, that's a partial fix. Okay, so what else are you working on? Like what else will you be working on?
We'll fix the rest of orphan attack, but that will require changing the
protocol.
Header version, yeah.
Okay.
Yeah, in that issue, I opened the issue for the height processed crutch. We need to figure out what to do with it.
Do you have any ideas? I mean, I
don't have a good solution.
Okay. Did you create an issue for the ishide process?
Yeah.
Okay. Okay. Yeah. We can discuss it asynchronously, I guess. Well, let's see if Alex, do you have better ideas?
For what?
Ishide process, like the attack that.
I didn't think too much about it. No.
Okay, we can discuss it asynchronously.
Actually, I think the good thing to do first would be to remember why exactly it was introduced. So I understand on the high level why it is helpful, but I think when we introduced it, we had a very specific attack in mind, which I don't recall.
Yes. I think when we introduced it, the idea is that you can start sending blocks on arbitrary heights and just doing that repeatedly. Because when we reject the block, for whatever reason, we don't actually store anything before. We don't store anything related to that. So you can actually just send it again, and you can just do this repeatedly, which is a problem. So they're like, even a single guy can kind of overwhelm you.
Yeah, I think it's solvable. We just need to
Sure.
think about
Okay.
it. We can do it. Well, we can do it today as well if we want to. If others would like to stick around longer and think about it.
Okay. Let's first. Do you have more updates on this on syncing?
No, I didn't make any progress this week.
But do you think it's reasonable to get it done by the end of the year?
Yes, absolutely.
Okay. Yeah, then I guess we're on track. So I investigated some issue with performance issue with network, and also worked on calibrating inflation. Yeah, so I guess that's pretty much it. Do we want to discuss the brainstorm the issue with the attack? Or
Yeah.
okay,
let's create a whiteboard.
yeah, actually, I think we can use the whiteboard on Zoom. Or do you want to create separate
Oh,
one?
let's give it a try.
Well, I tried it last time. It's kind of.
Well, also remember I have an Ubuntu, right?
Oh, you. Oh, okay, I see.
You can see a line.
Yeah. Okay.
So
Yeah,
remember
if
that
you're
this
going to.
doesn't work.
Okay. Yeah. If you're going to share, let's